Hi everyone, and welcome to How Kubernetes Brings QA and DevOps Closer Together, a practical approach to DevTestOps. I'm Nils lead QA engineer at Humanitech. Today we'll talk about Kubernetes, the concept of DevTestOps, as well as a robot framework library called KubeLibrary. The KubeLibrary was initially created by my co-presenter Michał in early 2020, but let's hear from himself.
Hello, my name is Michał. I'm a DevOps engineer at BNY Mellon. The motivation behind KubeLibrary was simply to ease Ansible and Terraform development of a Kubernetes platform I was working on at that time, something that could be used in CI, for example. At the beginning, it was just doing very simple tests and handling multiple clusters, but at some point I've decided that it might be useful to put more efforts on testing capabilities to make it useful for other people. Then Nils came in saying that he was thinking about something similar, and here we are showing other people what we are working on for the past few months. Nils, can you tell a bit more how KubeLibrary helped you with your work?
Sure thing, Michał. At Humanitech, that's why I'm working. Our product is an internal developer platform. Think of a platform as a service like Heroku, but with the possibility to connect your own tech and tools, like your Kubernetes clusters. For example, when I test deploying with Humanitech, I need to be able to verify that the application I just deployed is successfully running inside my cluster. Before the KubeLibrary, I was only able to check if my application was available. And if it was not available, I had to analyze the issue manually. Now, with the KubeLibrary, my test automation checks directly inside the cluster if everything is available and ready to test. I even get the application container logs and show them inside the test report. So we figured that the KubeLibrary will also be useful to others, as it helped me to deal with some of the common challenges in test automation. To give you an example, when I look at a report of a failed test, I need to be able to do a root cause analysis as quickly as possible. Let's say you have a failed UI test, which could not reach the page. Is the front end correctly deployed? Is the service available? Is the app correctly configured? A root cause analysis, or in short RCA, can take a lot of time and resources. Some issues can be infrastructure related, where I need the help of a DevOps engineer. So over to you, Michał.
As Nils mentioned, some of the RCAs can lead to infrastructure problems, but infrastructure itself is such a broad topic. Imagine a common scenario where service is not reachable. Is it network problem? Maybe someone just changed the way it is exposed. Maybe it just crashed. What about storage? Is it available? How do we handle upgrades with data persistency? And the questions goes on and on. I was once working in a team responsible for corporate private cloud, and the way they addressed health of the infrastructure is by running recurring tests every couple of minutes. But there was no sense to run hundreds of tests against OpenStack, storage, or front-end API. What they did is to run just simple tests, checking if the volume can be mounted, if the VM can be created, and so on. Digging into the root cause of a problem whenever one of those tests fails is another story, but you can imagine how complex the whole thing was. Notice I didn't place any of it in any specific context, as it's common for most of the services. 7 years ago, Kubernetes was born with the aim to abstract those common pain points in a declarative API. So from now on, you could define how many replicas the service has, what crash for this service means, what storage it needs, how it is exposed, and how to handle upgrade with data persistency, and many more. You could even create your own object if you want. But it's not about containers only, as in Darren Shepard's tweet I really liked. It's about API representation of all the surroundings of the container handling.
So Kubernetes is great, but how can QA and DevOps work closer together? Thankfully, there's a concept we can adapt, which is called DevTestOps. So DevOps as a principle describes this infinite loop of plan, branch, code, merge, build, release, deploy, operate, monitor, and then starting again with planning. DevTestOps additionally focuses on the requirement of continuous testing for all steps of this paradigm. Kubernetes gives us the possibility to control and check our infrastructure and applications, while Robot Framework gives us clearly structured and readable tests. So, in order to bring DevTestOps to life, we decided to fuse the best out of two worlds. Now Michał will go more into detail about the KubeLibrary. Enjoy.
I think the easiest way to introduce KubeLibrary is to go to its GitHub repository. KubeLibrary is a robot framework library for testing Kubernetes cluster. In essence, it's a wrapper around Kubernetes API Python client with additional logic for things like, for instance, resource filtering. Target API is very broad, so at this point we are not covering all the objects. You can always visit Robot Framework docs of the library to see all of its capabilities. You should find there all the details needed to run each keyword. The project has also a lot of examples. Actually, we try to cover each new keyword with examples, which are then executed in CI so that we are sure that you can use it without any problems. To run all of the test cases, I would have to spin up a couple of services, so for the sake of this demo I will just focus on one of it. This way it will not take too much time, but still you will have ready recipe to run it on your own. Okay, so let's start with cloning the repository. Then going into the directory and creating virtual environment. Then we need to activate it and install all the dependencies needed for the test cases. By the way, I will be using K3D Kubernetes, but obviously you can use anything you want. It is just fast and I can run fully qualified cluster on my own laptop really easy. I will start with spawning Grafana service using Helm Kubernetes Package Manager for that. Just need to copy a little snippet from the README. Paste it here. And those are the three steps I need to take. So first one is adding the repository of the Grafana chart, then updating it, and the last one is just installation on the cluster. App is starting and I can now pass some testing parameters. So back to the README again, copying the parameters. And setting those variables on my shell. The tests we are going to execute are generic, so we need to set a couple of parameters to make it fit to what we are actually testing. I'm sure Grafana still needs a little more time, so let's visit some of the test cases which we will be running in a second. So I will go to test cases folder, which is containing all the examples I was mentioning. And then system smoke. At the top you can find some of the parameters that are used in the tests, like for example Kubernetes version. And then we quickly scroll to the Grafana tests, which we are mostly interested in. Those are written in given when then manner, so hopefully it's very readable. Also, if you are not familiar with Kubernetes, I think you more or less know what is going on here. So we are testing if Grafana is persistent, if it has a 1 GB storage, if the service is pointing to the actual application, if the port is correct, and if we can really reach the endpoint. Then if we want to go and see how the deployment is going, we can go to the corresponding test in deployment and list all the deployments in namespace, show the Grafana deployment, and make sure that it has enough replicas. Before running the test, we could check if Grafana is up and running, and I'm gonna use kubectl for that. So we can just run kubectl get pods to see if the container is there, and also check if the services is exposed. Usually you would run this kind of tests manually, but with KubeLibrary you can run a couple of them with single command and use in CI or local development. I think we are all set, so let's run the robot on Grafana tags. And yeah, I will pass it to Nils and see how it's going on his end.
I hope you now have a pretty good idea how the KubeLibrary is working. So let's take it a step further. I would like to show you how you can use the KubeLibrary as a prerequisite of a UI test. By adding checks if your system under test is fully available and configured in the right way, you can make your tests less flaky. And if they fail due to an infrastructure or configuration problem, they'll fail much sooner, saving you precious time. Also, a root cause analysis in those cases should be much faster. So let's have a look at some test code. So for this example, I also decided to use Grafana as it comes with a nice little dashboard UI. So what you see in this test is basically it will verify a Grafana deployment using hell. And this part is quite similar to the test you've seen before. So it will basically check for the deployment object, if all replicas are running. It will check for the pods. It will check for the service object inside Kubernetes, the secrets, and the service account, right? But then what's a little bit more interesting is it will take from the service object inside the Kubernetes cluster, it will get the information on which URL and which port Grafana is actually running. Because if you don't define this, and you don't have to necessarily with a Grafana installation, then this will be automatically configured for you. And the same is actually with the login credentials. So when you install Grafana, it will give you an admin user, and it will give this admin user a random generated password. Right. So in order to obtain this password, we can look into the secrets object inside Kubernetes and get this password for us. So we can use it then in the next step in a UI test to log into Grafana itself. So let's look into a little bit more details of those custom keyword definitions. So what we have here is get URL and port from service. So this is using the KubeLibrary keyword get service details and namespace, and it will pass on the name of the service, which is Grafana, and then the namespace. And you can see here that what we need is basically inside the service details object, and we need to navigate down this YAML structure inside Kubernetes down to status, load balancer, the first ingress object, and then IP. To obtain this. I'll show this to you in a second in the test report. It gets more clear when you see the whole object. And similar for the port. And then for getting the secrets, we're using the keyword get secrets in namespace. In this case, I'm using a regular expression to exactly get the secret with the name Grafana. And the namespace is again default. In this case, because all informations and secrets are stored base64 encoded, I need to use the keyword evaluate and then base64 decode to be able to decode what I find in this YAML object. And the same then for the password. And after I obtained all this information, I'm able to log into Grafana, right? So we will use here in my first ever written browser library test, we will use the URL and port to navigate to the right page. And then we will use the Grafana user and the password to log in. And finally verify that we are now on the Grafana UI dashboard. So let's see how this looks. So you can see that the first part of the test goes quite quickly, as it's just API request to the Kubernetes API. And then the UI test is starting. It already was able to obtain the URL and the port and then log in with the username and the password. And that's it. All right, let's have a quick look at the test report. So here we can see that it was able to obtain the URL, right? And then inside here, so we are executing this get service details in namespace, right? So this should get us the whole object of the service. And thanks to this log output, we can actually see what has Kubernetes stored for us. So this is a standard here in JSON format, a standard object for a service inside Kubernetes. And down here in status, load balancer, ingress, and then the value for IP, we get the IP address. And quite similar for the port. And then with the login credentials, it looks a little bit different, because when you look into this object, then you can see like the admin password and admin user are both values which are encoded in base 64. So we need to obtain those two pieces of data, and then down here we will actually decode them, and then we get admin and this beautiful password. Yeah. That's it. That's all I have to show you. Thank you very much.
I hope you enjoyed our demo. Now you have a taste of what KubeLibrary can offer, and you have everything needed to take first steps using it. There are many definitions of DevOps, and a common goal among them is to just bring people closer together by using same tools and processes. Definitely Kubernetes has a huge potential, and with KubeLibrary you can now allow developer testing and operations capabilities to meet at a common ground, turning DevOps into DevTestOps. Thank you.
So that's a KubeLibrary. Thanks for your patience. So at any time, come to the GitHub project. Any contributions or questions are very welcome. You can reach both of us either on GitHub or Twitter, or in the Robot Framework community Slack. There's a channel called Kubernetes where we discuss anything Kubernetes related. You're welcome.
Hey guys, welcome to RoboCon.
Hey Joe.
Good to see you. Hey, how are you? All right, so someone just had a really quick question. How could someone contribute to KubeLibrary?
Well, we have an open source GitHub project. You can either directly check it out and do a PR, a pull request, or what you can also do if you're not sure how to do it or how to contribute, you can also feel free to talk to us on the Robot Framework Slack, for example.
Great. So we have a question from Dave Martin. He wants to know, do you have a keyword that can connect SSH to a port, example, via kubectl exec?
You mean
no,
like
we don't have. Yeah, you go ahead.
Yeah, I just wanted to ask if to clarify if it's like running the commands directly on the cluster, right?
That's what it sounds like. Yeah.
Okay, so I think we don't have it now, but yeah, you can always create the issue and we can discuss it.
Yeah.
So it could be doable. He could do it. Just have to mess around.
Yeah, I mean, it's absolutely doable. Like,
API.
I mean, anything which is offered through the Kubernetes API can be also done with the KubeLibrary, right? So it's just a matter of coding.
How much code would that take to do to implement that?
It's actually not that much, right? So because all the code is already existing, there's the Python Kubernetes client provided from Kubernetes, and we are just writing the wrappers for it in our KubeLibrary, so we can reuse those functions basically inside Robot Framework. So it's usually not that much code.
Nice. Another question is, does this library also work same in Windows-based operating systems when you are writing your test cases?
Yeah, I'm on Linux, but I don't think that there should be an issue. Like I know a lot of people using both Kubernetes and Robot Framework on Windows, and I don't see any issue there.
Yes, underlying library is a Python, so it should work everywhere. Python is acceptable, right?
Perfect. Dave has another question. It is KubeLibrary with additional keyword functionality. Are you on? What additional keyword functionality is on your immediate roadmap? Do you plan to support, once again, kubectl scale to scale replicas up or down, and or kubectl exec to connect SSH to a pod? This is in place. Oh, sorry. So this was in place as his original question. I guess he just wants to know what's on the roadmap for any future additional keywords.
So
yeah, I don't know. Like
very open.
Yeah. So and also we already have a little bit of a plan. Like we have already put together like our 1.0 release basically. So we have already like 30 plus keywords available right now. So if you look at the keyword documentation, I personally mostly went for what I need for my current work, which is asserting that certain objects have been created basically inside a Kubernetes cluster. But we also have a first keyword which is actually creating an object, for example, a service account. So we have one keyword which is also which is able to create service accounts, for example.
It's actually someone's question that wants to know, how do you use the KubeLibrary in the real world at your company?
So yeah, to understand that, like in Humanitech, we are actually providing an internal developer platform. Development teams can easily adapt and basically maintain application development and configuration management and also deployment to Kubernetes clusters. So what I do in my test automation most of the time is actually verifying that whatever I do through the Humanitech API to deploy or change things inside a Kubernetes cluster, that those changes have actually been applied. And this is my main usage for it, basically.
Yes, on top of that, I can say that we are using kubeconfig as an input. We can also run the tests using in cluster. So you can just spawn a pod within the Kubernetes cluster that will be running the test. And this is currently the two ways we are supporting. But we are thinking of other ways of interacting, like, for example, bearer token authentication. So yeah, more functionality to be there in future, probably.
Because I missed this. How long has this library been around?
So I think it's about 1 year.
Yeah.
So Manny actually doesn't have a question. He's just impressed that even Q8s can be tested via RF. I already struggle with running things on Kubernetes. Testing it is totally out of my league. Not anymore with this library. So check it out, Manny.
Yeah, absolutely.
Jagan wants to know, do you have a library for Docker containers as well?
Well, as soon as you run those containers in Kubernetes cluster, then it's fine.
Yeah. You can basically, I mean, you can look into the into the container, right? So there's a lot of configuration which is already visible and exposed through the Kubernetes API. And for example, one thing which I like to do is when I deploy an application, I actually like to fetch the container logs and then check if there was any problem basically with starting the container up. So I can do this in my robot tests.
Simon wants to know, let's talk about security. You showed that the Grafana password was logged in clear text. Can you also access the cluster with the K8 library without the right to read application secrets?
Yeah, so this depends on how the kubeconfig, the authentication, and all those stuff are set. If you're speaking about running tests from within the cluster, it's basically the same thing. You have the airbag there and some permissions assigned to this container, right? So it doesn't do anything magically. It's the same that you could do outside the cluster, right? So as long as you can execute it as a user, then you could do the same with the library.
Yeah. Yeah, basically, like whatever service account you define to run your tests with has exactly the access to your cluster the service account should have. Like, there's no magic in between. It's the plain access to the Kubernetes cluster you're passing on to your test.
Someone else asked, do you have any general tips for testing Kubernetes?
Yeah, I like in general, I would say like it bears a lot of potential, right? So like I'm a big fan of having access to APIs, right? So once you have everything under control and can check through an API, you can add it to whatever tests and scripts you want. So like in general, like I think Kubernetes for me is a great addition to testing in general.
Awesome. Yeah, I love this approach with APIs. Thank you so much for this contribution. I think those are all the questions we have, and we're just on time. So before we go, though, any parting words of wisdom? You want to leave RoboCon?
You should definitely check out Kubernetes, and feel free to join us in the speakers corner. I think in the light area there's good space.
Yeah, and if you want to start with KubeLibrary, go to examples. We really try to get and put there everything, and it should be really easy for you to start using those examples.
Sounds good. Thank you so much. We'll check you on RoboCon venue as well, or any other questions you may have. Thank you so much for this library. I think it's really cool, good development going forward. Hopefully we'll expand on it. So thank you so much.
Thank you.
Thank you.
Thanks. Cheers.